Hello everybody and welcome to Gregg's Vintage Workshop, where I'm working to restore history one piece at a time. Tonight we're starting a new project, a little bit different. I like the Bakelite radios. This one is actually plastic, looks sort of like Bakelite, but it's a brown plastic, so it's not really Bakelite. But it's a GE Model 404, 1951 vintage. It's a radio that has frequency that runs from 540 to 1600 kilocycles. It's got a 6-tube complement, a 12SK7 RF amplifier tube, a 5A7 oscillator converter tube, a 12BA6 IF amplifier tube, a 12SQ7 detector audio amplifier tube, a 35Z5 rectifier tube, and a 35L6 audio power amplifier tube. I think this is going to be a pretty good little radio. It's not what I would consider the most attractive radio. It is unique. I got this radio about 2 years ago, I think. If you remember the RCA, the big console RCA, that I completely restored the cabinet as well as the electronics, it was the iTube radio. I bought that for $10. Well, this same guy is who I bought this little radio from. At the time he wanted $10 for it as well, and I was like, really? You're gonna sell me this great big console for $10 and you want $10 for this other radio as well? He's like, yeah. I was like, okay, well, I guess that's what I'll spend then. So anyway, I picked it up. And it's been sitting down here, and my daughter saw it the other day, and she's like, I like this radio. When are you going to work on this? And I said, well, I'll just make that my next radio. So that's what we're going to do, starting with this episode. So without further ado, let's check this GE 404 out. Okay, so here's that 1951 GE 404. And it's not in horrible shape, but it's not in great shape either. It's got a cord. It's probably the original cord, but I think that that's not the original end. But it's also not polarized. And this is a transformer-less set, so it needs to be polarized. So let's go ahead and plug it in, since they said it worked, and just see if it does anything. I'm going to put it into my electronic circuit breaker. And we'll bring the power up slow. Flipped on. Reset the breaker. Put that on. AC. Let's turn this on. Give it a little bit of power. Bring it up slowly. It's 45 volts. Get it back to approximately where a station should be up here. Dial cord does slip. It's operational, but it's slipping. I don't know if I can get it to where... Yeah, it's going to slip. I can't get it to a station area, but maybe we'll pick one up someplace else. It's drawing 50 milliamps. Let's go up with some more current. More voltage. There's 70 volts. It's drawing 90 milliamps. No sound out of the radio. Oh, I hear a hum. No stations coming in on the low end. if the dial cord could go further, it might pick something up in our local area, but nothing. Alright, I'm not going to take it more than that. It's got hum, so obviously the electrolytic is no good. I'm going to take it on apart and replace at least the last capacitor for the output, but we're going to have to restuff the electrolytic, or at least replace it. So let's go ahead and get it apart. So we'll start by pulling off the knobs. Got a little brass cone shaped bezel in there. One must be stuck in there. The other one obviously was glued in, but the glue didn't hold. Some clips here for the loop antenna. I got a feeling that it's held in with screws on the bottom. Yep. Look at you in here, look at this. So, besides having cobwebs on the side of it, it's pretty dirty inside there. But the actual speaker wires have no insulation on them. It's just wire. Let's see if I can unplug those from the speaker. Yep, okay. Well, that one unplugged from the top of the speaker. And that one unplugged from the bottom of the speaker. Pin that down so I can tag those. Alright, let's back you out so I can pull this out. Well, this is one of the dirtiest radios I've seen in a while. So this is what we're looking at here. And if you can see in there, that's a lot of dirt and cobwebs and crap in there for sure. Speaker looks okay from the back side. The actual cabinet, it needs some work. Good cleaning for sure. Top's pretty scratched up. I'll have to try and get all that out of that. Alright, let's set this aside. Spin this around. That is pretty nasty. Get you in a little closer. As you can see, that is pretty nasty. It looks like it might clean off though, where I just took that down. Right there. Okay, I think the next step is going to be we will blow that off. Let's have a look underneath first. See if this has been touched before. So we got a pretty rusty tube shield there. I don't think it has been touched at all. A lot of waxies in there. They're going to have to be changed. I think we'll start with checking the resistors and changing the wax capacitors. I probably won't restuff that electrolytic. It'll probably be easier just to relocate some new ones underneath. I only restuff if it looks like it's easier, and I don't think this one would be easier to do. So it looks very clean underneath, considering what it looks like on top. Okay, as you can see, this wiring, there's no insulation on that at all. Alright, I'm going to take it out and blow it off. I find this dial pointer pretty interesting. I think it's a piece of plastic that is crammed into a little channel on the metal arm, but it's all warped and distorted. We'll have to try and flatten that or make a new piece. We're going to start by taking that sloop antenna off of here. It's an interesting plug. Pins. The wooden dowels that are drilled. I'll set this aside. Let's see how this is going to clean up. Not too bad. I blew it off with air compressor. It didn't hardly do anything to it, so we're going to brush it off, then blow it off. The tube shield here is very, very rusty. I'll have to put that in some evapor rust. Okay, I'll take this off camera and I'll bring you back after I get some more of this off of here. Take a look and see what it looks like. Okay, it's a little bit cleaner. What I noticed was this was trying to come off, so I want to get this captured. So this is just a piece of black paper. Looks to me like I need to clean that up. Looks like it might have some felt, like some black felt on that. I might have to try and remake that because it's rotten. And it's attached to a piece of cardboard here, which must just be glued onto this. We can probably save that. Maybe. Let's see how it comes off of there. So it appears that this front plate is held on right here and right here with just twisted metal. I'm going to try and take that loose and hopefully not snap those off. It looked like it turned pretty easy. There we go. It looks like the dial string was in that slot on each side. Okay. Okay, so the outside cleaned up pretty good. I just rubbed it down with a little bit of rubbing alcohol for now. I might go back with some Brasso later, but for now, it's not too bad. I want to get the tuning capacitor off of it. I've done destrung it, got the string off. I've got the wires desoldered from it. The problem I got right now is, in order to get to it, there's 3 1/4-inch head hex screws in there. 2 of them are easy to get to, and the third one's underneath this coil here, which is all soldered onto that tube. It's not going to be easy, but probably going to do some desoldering here, because I got to get that out anyway to get to that cap underneath there, so that's going to be tight. So let me see if I can get that. I want to get the tuning condenser off and get it soaking in some evaporust. Okay, I got the tuning condenser off. I'll put that in some evaporust along with this tube shield. The actual grommets that were in there are actually not bad at all. They're still pretty pliable and soft. I can probably reuse those. I do have new ones. This one a little more iffy because it's kind of crushed looking. It's still soft, but it's crushed a little bit, so I might reuse 2 and replace 1. Or I might just replace all 3 of them. It's not like they're that expensive. Okay, so I've pretty much finished up the cleanup on this outside of this chassis. I think overall it turned out pretty good. I think I'll probably wind up running to the store and buying some black Testors model paint and repainting this black. It's pretty chipped up. Put a piece of tape down for a straight edge and we'll touch it up, but for now I think we're going to go ahead and get started on the recap. One thing I did notice as I was looking at this, let's see if I can zoom in a little bit. You can really see here where that cap melted. Right here it melted some goop out and it glued itself to that resistor. So obviously I'm going to replace all these caps and we'll check the resistors. And I'm not going to show you that. You guys have seen me recap before, so I'll go ahead and get this recapped and I'll bring you back. Okay, I thought I'd bring you guys quick back and show you where I'm at right at the moment. I replaced this 2-section 50 microfarad 150 volt honking electrolytic with these 247s down here. Put a terminal strip in, mounted in real nice. That worked out real well. And then I replaced this 68 ohm resistor because the one that was in it, which is what's on my meter right now, as you can see, was reading 147 ohms. So that wasn't good. Then I replaced this 150 ohm resistor right here because it was reading 214 ohms. There's that cap and that cap. Let me show you on the schematic. This should show up or not. I'm not sure if it'll show up or not. This is the power amplifier tube. This is the C14 cap. And that one was this one right here. This is C14 on the power amplifier tube. And then this one is 0.05 that got replaced with 0.056. And it is this one right here. Get you guys in this where you can see this. Go ahead and move on, but right now not looking too good for a lot of the resistors. Now a couple of resistors have tested fine. No, right here, this one and this one, these both tested fine. They're within tolerance, so I didn't touch them. So I'm going to go ahead and get rid of the rest of these resistors and capacitors, and I'll show you the casualty list when I come back. So this one's a 22 ohm that just checked out at 38. I want to show you that I've been using the coil method on all of these component changes because the tabs on these tube sockets aren't the strongest looking to me. So it's just easier to do the coil method and not have to mess with the ones on the sockets. Okay, so the recap and the resistor replacements are complete. I wound up replacing 5 resistors that were out of tolerance. I had that 168 ohm that was reading in at 145 ohm. I had 150 ohm that was coming at 214 ohm. And then I had a 22 ohm that was coming in at 38 ohm. And then I had a 4.7 meg that was coming in at 6.1 meg, and a 470K that was coming in at 610K. So I changed all those. Any other resistors you see in here, such as this one here, that one, that one, that one, that one, those were all within tolerance. Placed all the caps, wrote on them the values. So I think I'm ready now to, oh, I also sprayed Fader Lube into the pot. Getting ready to put the new bushings in and put the tuning condenser on. But also what I want to do is I think I'm going to mount a fuse right around here to fuse it, and then put the new power cord on it. So let me get that done and we'll be back. Okay, so the bottom is done. I got all of the capacitors changed out. I had missed one under this particular transformer, but I got it. Also added a 1/2 amp fuse and holder right here. So let me flip it over and show you the top side. So here's the top side, and looking pretty good. I had to rebuild the wiring for the dial lamp because they were rotten right here where they come through the hole of the chassis. I tested my tubes, and I've got 2 bad tubes. The 35Z5 had bad grid emissions, as well as just tested bad. It had some shorts. Quality just was bad. And then the 12SQ7 also tested bad. So I'm going to have to get some tubes on order. So I guess this is a good place to end part 1. So from Gregg at Gregg's Vintage Workshop, thanks for watching.